Greetings, everyone. Today we're going to explore determinants. You'll need your notebook for this, and we're going to take a look at how we can find the determinant of a matrix. In your notes, please make a small left column so that when we go back, if we need to make any notes before studying, we have that option available. So we're going to stick to determinants of just a 2x2 and a 3x3 matrix. Anything beyond that, it is possible, but once we get going, you'll see why we are not going to go any larger than that right now. So first of all, let's talk about what a determinant is. A determinant is a number that is associated with a square matrix. It's noted as, it's going to look like the absolute value symbol, or we can say determinant with DET abbreviated and then parentheses A. So that's just the notation that will help you understand what we're looking for. To find a determinant, you must have a square matrix. So what that means is if it's not a square matrix, then it does not have a determinant. Okay, so we're going to stick to squares. It makes it easy once we go through the steps. It'll make sense. You'll understand the why we can't find a determinant for a non-square matrix. Let's start off with a simple 2x2 matrix and find its determinant. You don't have to write this down. Let's just briefly talk about how we do this process. This is very systematic, so if you like the math that's sort of step by step, you'll very much like finding this determinant. It does get some involved steps, so just make sure that you watch this once through, and then we'll actually add some to our notes. So here I have a 2x2 matrix, and to find the determinant, which is a value of this matrix, the first thing you want to do is look at the downwards diagonal from top left to bottom right. And you're going to take those values and you're going to multiply those values. Okay? And you're going to end up with a number. All right? Then you're going to go up from bottom left up to top right. The other diagonal, so we've covered all diagonals this way, and you're going to multiply those values, okay? And you're going to end up with a number. Now those two numbers, if I want a single number answer, I'm going to have to subtract those two values. Okay, so let's look at it another way. I'm going to start by saying A times D, take that diagonal. Once you have the full diagonal figured out, then you're going to subtract the entire other diagonal. Okay, that will lead you to a final value. All right, let's take a look at a couple of examples so we can actually apply and see this process work. So to start off, I need to look at my first diagonal. Always start with that top left corner, and that'll help you find your first diagonal. So I have a -5 times an 8. I know these are going to be simple math facts, but to start off, I'd suggest actually writing it out. Once we get more comfortable and we move into the other processes beyond this, then we're going to move from that. But for now, let's write it out. All right, so if we multiply that out, we end up with -40. Watch your signs there. Then we need our other diagonal, which is 11 times -7. So that gets me to -77. And what we're looking at here is the difference of our two diagonals. So in this case, definitely have to watch your signs because subtracting a negative is going to change to adding. So our determinant is going to be 37. Okay. All right, let's take a look at one more. In this case, we're going to start with our first diagonal. So I have 3 times 5. We end up with our 15. I'm going to look at my other diagonal. which is 2 times -1, which gets me to -2. I'm finding the difference of those, so we end up with a determinant of 17. So 2 by 2, pretty easy, right? There's not many ways you could mess this up. But let's take a look at finding a 3 by 3 determinant. This definitely has more steps. You don't need to write this down, but let's just take a look. If I was to follow these generic rules that I've already set out, that would be top left, create a diagonal. You'd multiply these values, and then I'd look at my other diagonal, and I'd look at those, and I'd have these values, but I'm trying to find the determinant of the entire matrix. And I've got a problem here. I haven't even touched these numbers, okay? To find the determinant, it describes the entire matrix. I need to include the entire matrix. So we need to update our process to meet those needs. So let's go through just some steps before we actually apply this process. If you need to pause at any time, make sure you do that to take these notes. That way you can fully pay attention to the ideas. The first step, we want to rewrite the first 2 rows of the matrix on the right side of the matrix. And I apologize, there's an error there. This should say rewrite the first 2 columns of the matrix on the right side of the matrix. We're literally just copying 2 columns outside. Step 2, you want to multiply the diagonals going down and add each diagonal. So this is still the same. We're still going to multiply the diagonals, but now we're going to have multiple ones. So we need to add our multiplied values. Then we're going to take the up diagonal. So from the bottom left, we're going to go up. Same thing, we're still going to multiply, but we're going to have multiple diagonals, so we're going to have to add those. And then just as before, we want to find the difference. So we're going to take the bottom and we're going to minus the top. All right, so let's go through and actually apply these steps, okay? So to start off, we want to take the first 2 columns and we want to copy them to the outside on the right side of my matrix. So that means I'm going to carry over that -2, 6, -4, and carry over that 3, 7, and 5. So literally it's copy, paste. No math involved here so far. Now, if I start taking a look at diagonals, you'll notice I've got 1, 2, 3 diagonals where I capture all 3 values. So now I'm taking care of everything and I'm not missing any single values. And then when I look at the other diagonals, if I go up, every number's been used at least once. You might be like, hey, that's 6 and 7, but hey, that 6 and that 7 were covered here, okay? So we're covering every number when we take care of our diagonals. So let's do this piece by piece. Let's start with our first diagonal. We're going to treat it the same as a 2 by 2 and start by multiplying. Now, I like to write the multiplying just right below the diagonal that I'm working with. So -2 times 7 times 9. You could solve that right away if you want to take care of it. So we would end up with -126. All right, let's keep going though. I have this diagonal. This diagonal is 3 times -1 times -4. Let's take care of that right away. We end up with 12. And our third diagonal that covers all 3 values, we end up with 8 times 6 times 5. And that gets me to a value of 240. All right. Now, these are all going down diagonals. So we need to combine them all into one value. So we're going to add the diagonals together to get a value of 126. Okay, so be careful with those signs because that can definitely make a difference on your total then. All right, let's talk about our other diagonals going up. Okay, so in this case, I'm going to write at the top because that's the direction I'm going. I'm going from the -4 times the 7 times the 8. That gets us to a value of -224. My next diagonal takes care of 5 times -1 times -2. So that gets us to our +10. And our third diagonal is a 9 times a 6 times a 3, which gets us to 162. So those diagonals need to become one diagonal value. So I need to combine those to get my total of -52. Okay, so easy math, right? These are basic math facts. If you need to use a calculator, go for it, but it's the steps we have to be careful of. So again, copy and paste the first two columns, 3 diagonals going down, 3 diagonals going up. Now those two values I need to put together. I only want one number for my determinant. Okay, so to take care of that, we're always going to do the 126. We're going to subtract the -52. So think about this. You found the 126 first, okay, by going from top to bottom. And notice I wrote it on the bottom, so maybe think of your bottom totals. Maybe that's a way to think of it. That's why in the steps I said bottom, because they're the bottom totals is where I wrote them. And then we're subtracting the value we found a second, or maybe you want to say the top totals. Okay? You have to find, what connects with you to help you remember that. Okay? So bottom minus top, or first minus second. In this case, we have subtracting negative again. So our final determinant is going to be 178. All right, so we would say our determinant is 178. All right, now we know that number as of right now doesn't have a lot of meaning, okay? We're going to turn that into meaning in a future lesson. Today, I'm just worried about the process of finding that value. All right, let's go through one more because I know this is new and there's quite a bit of steps I'm looking at. So without the fancy highlighters, you can decide if it's good for you to highlight, if you're better at circling, you decide. Either way, our first step is to copy and paste our first 2 columns so that we can actually capture every single number. So first of all, I have a 5 times -3 times -3. That gets me to a value of 45. Then I have a value of -1 times 5 times 3. So that gets me to -15. Then I have my last diagonal going down, which is 2 times 2 times 2. That gets me to 8. Okay, I want to find this total of those diagonals. So we end up with 38. All right, let's capture our other diagonals. So this time I'm going up. So I have 3 times -3 times 2. That gets me to -18. I have 2 times 5 times 5, which gets me to 50. And I have -3 times 2 times -1. So that gets me to +6. I need a total for all of these. Combine those, we end up with 38. Now, if I'm going in order or bottom to top, I need to find the difference of what I found first, and I need to subtract what I found second. And in this case, we end up with 0. The determinant is 0. So again, I know that doesn't have a lot of context or meaning yet, but this will have great meaning in the future when we talk about inverses. Okay? So to start off, all I need as of today is just for you to tell me that the determinant is 0. All right, so looking ahead, just make sure you have these notes on determinants. Oops. Make sure that everything else is caught up. Do you have all your homework in? As always, I'm sure I'm working on updating grades, so those will be updated soon. If you have questions, please let me know. We're really going to get into some tough stuff coming up in the sense of it's not something you've done before. Okay, up to this point, you've done some form or close to a form of everything we've done. This is new, okay? So that means that's planning a time to visit with me, that's planning a time to get into the Sabre Center, that's planning a time, maybe just in your schedule to sit down and re-listen to a video or rework on some problems. But you're gonna need some time in some form or another in these next few lessons. So please take advantage of that and let me know if we need to visit. Until next time, have a good day.